Good afternoon, everyone. I'm Elizabeth Feakin, and today I'm speaking on behalf of Living England and the work that we've been doing for object-based change detection for habitat monitoring. The Living England Habitat Map displays the extent and distribution of England's diverse habitats. This project started in 2016 and uses satellite imagery, machine learning, and a national programme of targeted field data collection. We aim to publish a new map every 2 years under Open Government Licence, and our project is funded by DEFRA's Environmental Land Management Schemes and the Natural Capital Ecosystem Assessment Programmes. This work is part of DEFRA's wider goal to reverse the depletion of nature in the UK. So this is our team. We're lucky enough to have both ecologists and Earth observation analysts in our team, which means we have an interdisciplinary approach to the work that we do. The Living England project is a complex project with a number of different elements. The first is field survey data, which we collect both in-house and through external contractors. We use a number of different Earth observation data sources, including Sentinel-1 and 2 and LiDAR, as well as other geospatial data sets. We use a random forest model for our machine learning model and produce a national habitat probability map. So far, we have 2 iterations of Living England, one from 2020 and 2021, and one from 2022-23. And naturally, we're interested in looking at what the differences are between these 2 years, so we aim to publish a change detection map every 2 years at intervening years. Here are a few key goals for change detection. We're looking to update the spatial framework and ensure that it represents the extent of changes. We're looking to update the method for modelling and ensure that the changes that we see are due to changes in habitat rather than just variation in the model. And we're also looking to develop a reliability metric to measure the confidence of our map change. This is an overview of the change detection work, and I'll go through this step by step. So first is the reprocessing. We're reprocessing Living England 2020 and 2021 with our new method, so this includes improved segmentation, improved bare ground mapping, model optimization and reporting, a new reliability metric, and a new desktop validation app. Next is the spatial framework. Living England uses an object-based method, so this is a combination of chessboard, multi-resolution and spectral difference segmentation using these variables you can see here. So there's a Sentinel-2 biogeographic zone boundaries, some canopy height data and ordnance survey data. We decided early on in our change detection work that thresholding would be a very key element. So the goal of this is to find candidate segments where change might have occurred. So we're using the zonal statistics for all satellite-derived bands for each segment, applying a Spearman's rank correlation to quantify the differences between the years, and then testing correlation coefficients between 0.8 and 1 to quantify what we imagine might be real change worth further investigation. So the resegmentation has the goal of creating a new geometry that aligns with the boundaries of changes. So we're using a novel method which takes the first segmentation and then uses this to constrain the new segmentation that we're inputting. So we've taken the candidate segments and then resegmented it, and then the next stage is to merge this with the first year to have an overall segmentation. And this moves on to the modelling. So as I mentioned, we carry out our own field survey data, and we also use other Natural England survey data, including the long-term monitoring network, England Peat Map, and other surveys. We also use Earth observation data, so Sentinel-1, Sentinel-2, LiDAR, some climate products, geology products, and soil products as well, just to name a few. And we put this into a random forest model to produce our habitat maps. We decided that it would be best to use a single model for both years, so we are using data that's trained on multiple years. So we're using data from 1991 to 2021 and the data from 2020 and 2021, then 2022-23 data and the associated year to create combined zonal statistics to produce our multi-year model, which is applied to both years for change detection. We're still trialling a number of different variations on this model, but this is definitely the way we're going to move forward. Next is validation. So we're using targeted field data collection to look at segments which we believe might have changed. So we're looking at segments with 80% and 90% correlations, less than 80 and 90% correlations of satellite-derived variables between both years. So you can see on the right, the red segments are showing that it's got a relatively low correlation between the 2 years, and orange similarly so. So these are areas that our field team are going to target. We're also looking to acquire external data from stakeholders and partners. So what we need is field data of broad habitat changes with a spatial location and a time period. And if this is something you think you could help with, please speak to me afterwards, or alternatively email the address here. And what we can provide is the opportunity to contribute to one of the government's leading AI projects and England's only nationwide habitat map, openly available, and also gain early access to our change detection product. Next is reliability. So we already use a reliability layer in our product, mainly based on the probability of our outputs, but we're looking to enhance this with more ecological knowledge. So there's a total of 20 classes, and we're looking at the 400 possible habitat transitions and measuring the likely timescale of these changes to then level up or down the reliability. And we're doing this by exploring also the spectral signatures between these transitions and comparing this against our habitat matrix. And we also want to quantify those key changes in reflection at different wavelengths. And finally, post-processing. So we're going to merge the segments with bordering segments of the same class if they've changed, and then also apply a segmentation ID over time to track this. And this means that whilst we're doing change detection, we're never going below our minimal mapping unit of 300 meters squared. So this is to repeat the workflow. So we've taken both years of data and put it into 2021 segmentation, done a thresholding to produce candidate segments. These segments are then put into our segmentation method to constrain it, then merge and to produce our provisional segmentation. Apply this to 2022-23 data to get our zonal statistics and the Living England model trained on multiple years, to get the provisional map and apply the ecological knowledge to the map, post-classification, and then this produces our map. So what's next? We've got a lot of exciting things on the horizon. So we're currently merging the thresholding and segmentation approaches, trialling more variations on the multi-year model, expanding our habitat transition spectral signatures, looking at collecting more change detection field data and acquiring external data sources, and developing a segmentation ID schema, and finally implementing Sentinel-2 texture layers. Thank you for listening. I'd like to invite any questions.
Fantastic, thanks very much. Any questions? I'm going to Chumbo first, then I'll run up back.
Thank you for the very interesting talk. Brilliant. So I have one question. When you detect the changes, when you try to detect the changes, do you use two inputs of data collected from two different times? Or do you, for example, do the detection first and then do the comparison after that?
So, yeah, that's a really great question. So what we're doing is taking seasonal mosaics from 2020 and 2021, so there's spring, autumn and summer, and we're doing the same thing for 2022 and 23, and applying the model to both and then looking at the differences.
Yeah, thanks for that very nice talk. You mentioned that you're specifically not looking at habitat degradation in your...
Condition.
Yes. Oh yeah, condition. So my question is then, is there a distinct signal difference between, let's say, habitat condition or degradation and habitat change?
Yeah, so we're looking mainly at the habitat changes because we're applying the model which already kind of has an existing labeling system of exactly saying what the habitat is. It will be quite tricky to determine when something is more of a transition rather than a change, but we're looking for those quite significant changes between the 2 years to classify.
Thanks. Anybody else?
Thanks. Hi, thanks, that was a really good talk. I'm just curious about the collection of field observations, and you've made this call for, I don't know, people to help with that. But I'm wondering, what kind of technologies do you use for that at the moment? Because I imagine if the field observations are made by people, are they then... You would need loads of people. I don't know how many people you have. Or are you using things like drones as well these days?
We are just using people within our team, so they are also looking for change detection. It's not something that we can use. There's not enough data to create a change detection model on its own. So what we're looking for is validation sources. So any sources that indicate these habitats have changed from one to the other. But yeah, I do appreciate it is quite difficult when it's people on the ground and it's a bit harder to validate. But yeah, we're mainly using those two methods at the moment.
Okay, well, thanks. Yeah, I might speak to you after. Thanks.
Anyone else? I have a quick question. I'm always curious about the kind of the workflow decisions that were made, and you obviously opted for this segmentation in the first instance, and then you kind of using the area averaged covariates to build your model. Was there a decision like reasoning behind that? Was that a computational decision, or?
Yeah, it's mainly based off literature as well, where it's a lot easier to manage these larger scale habitats by putting them through objects, and it also avoids that kind of salt and pepper effect, which often has with using pixels. But yeah, it does definitely make it more complex with change detection.
Great. And, well, thank you very much. Brilliant. Thank you. If Elizabeth Galloway could come and set up the next...